Assalamu alaikum everyone. This is worksheet number 4A on page 12. Alright, so the topic is number sequence. Look at the given table. What is that telling us? That the first term is 2. The second term is 6. The third term is 10. The fourth term is 14. So what is happening in between? How is 2 changing into 6? By adding 4. How is 6 changing into 10? By adding 4. How is 10 changing into 14? By adding 4. So that means we can get the fifth term by adding 4 here, and we'll get 18. And then to get the sixth term, we'll add another 4 to get 22. So this is the kind of sequence that has a common number being added to every number. So how can we find its 57th term, or let's say 1000 term or 10,000 term? We can do that by generating a particular formula for this term. We'll see how to make this formula later, but for now let's see how we can use that. N is the number of term. So if the number of term is 1, if n is equals to 1, notice if you put 1 in this formula, do you get this answer 2? Yes, we do. And if I put 4 here, 4 times 4 minus 2, do I get the answer for the fourth term, 14? Yes, I do. So you can substitute the value of n and get that particular term. So how will we get the 57th term now? By substituting 57 instead of n in this formula. So when I write 4 times 57 bracket close minus 2, this will give me 226. So the answer here will be 226, and similarly if I write 58 instead of n, I will get 230. So this is the advantage of getting the formula for a particular sequence, and we'll study different types of sequence in this chapter and learn how to make the formula for that. The first type of series or sequence is the consecutive number sequence. The first number is 1, the second term is 2, the third term is 3, the fourth term is 4. So similarly, after 7 will come 8, after 8 will come 9. So the nth term of this sequence is simply n, because if I want the 8th term, it will be 8. If I want the 28th term, it will be 20. So if I want a random n term, it will be n. So that means its 50th term will also be 50. Part 1. Now notice that from the original sequence, I have removed one number. When this happens, how can you deduce the formula for this sequence is that you write the original sequence, and then since you've removed one number from it, you actually add one here. What is happening over here? We've removed two numbers from the original sequence, so I write the original sequence and then add 2. It's actually the opposite. What's happening over here? I've added an extra number before the original sequence. So now I'll write n minus 1. In part 4, I've added 2 extra numbers. So I'll write n minus 2. And in the last part, I've added 3 extra number to the original sequence, which was 1, 2, 3, 4, 5. So I write n, which was the original sequence, minus 3. Now for this, the 70th term will be 70 plus 1, 71. The 35th term for this will be 35 plus 2. 35 plus 2 is 37. Then 22nd term will be 22 minus 1, 21. 65th term will be 63, and 70th term will be 50. The second type of sequence is a square sequence. So 1, 4, 9, 16, 25, 36. We can easily tell that 1 is 1 square, 4 is 2 square, 9 is 3 square, 16 is 4 square, 25 is 5 square, 36 is 6 square. So 1, 2, 3, 4, 5, 6. Now the seventh term will be 7 square, 49. And the eighth term will be 8 square, 64. Hence the nth term will be n square, and so the 12th term will be 12 square, which is 144. Now let's shift this sequence. I have removed one number from the original sequence, so what will happen, instead of this n, I'll write n plus 1 because I've removed one number. So I write n plus 1 whole square. Remember, it's whole square and not n square plus 1. This will be wrong. So here after 49 we'll write 64, and after 64 we'll write 9 square, 81. Now here we have removed two terms from the original sequence, so we write n plus 2 whole square. Again, some students end up writing n square plus 2, which is completely different, so be careful about that. So this is also 64 and 81. So now the 19th term for this sequence will be 19 plus 1, 20. 20 square is 400. And 38th term for this sequence will be 38 plus 2, 40. 40 square is 1600. Cube sequence, the first term is 1 cube, the second term is 2 cube, the third term is 3 cube, the fourth term is 4 cube. So the fifth term will be 5 cube, which is 125. The sixth term will be 6 cube, which is 216. So nth term will be n cube, and 20th term will be 20 cube, which is 8000. Okay. Shifted sequence, I have removed one number from the original sequence. So instead of this n, I'll write n plus 1 whole cube. In the second series, I have removed two numbers from the original sequence, so I write n plus 2 whole cube. Now the 29th term will be 20 plus 1, which is 30 cube, which is 27,000. And then the 48th term for this particular series will be 48 plus 2, 50. 50 cube is 125 with 3 zeros. 0, 0, 0. And let's fill this up. After 125 we'll write 6 cube, 216, and then 7 cube, 343. And same here, we have 3 cube, then 4 cube, then 5 cube, then we'll have 6 cube, then we'll have 7 cube. Then we have a past paper question which says, find the nth term of 2, 9, 28, 65, 126. Now this isn't a particular term we've studied yet, so we will have to break this down. This is actually 1 cube plus 1. Then you have 2 cube plus 1. Then you'll have 3 cube plus 1. Then you have 4 cube plus 1, and so on. So the nth term will be, this is 1 cube, 2 cube, 3 cube, 4 cube. So the nth term will be n cube, and then you'll have to add plus 1 to it. Alright, the fourth type of sequence is linear sequence, or it's also called first level common difference sequence. So look at part 1. It's 2. The first term is 2, the second term is 4, the third term is 6, the fourth term is 8, the fifth term is 10, then the sixth term will be 12, and then 14. Now what is happening in this sequence? We are adding 2 to every number. So this is actually the table of 2. So the table of any number, its nth term will be 2n. If it's the table of 8, its nth term will be 8n. If it's the table of 5.5, let's say, then the nth term will be 5.5n. So we don't need to get into this formula. We'll use this later for the more complex ones. Okay, now look at part 2. Part 2 is 5, 10, 15, 20, 25, 30. So next we get 35, next we get 40. So what is this? This is simply the table of 5. So the nth term is 5n. I missed the 11th term over here. The 11th term for 2n will be 2 times 11, 22. And the 20th term for 5 will be 5 for 5n will be 5 times 20, which is 100. Okay. Third term, 2, 5, 8, third question number 3, 2, 5, 8, 11. Now what's happening over it? It isn't a table of any number. It's what's happening, we're adding plus 3 in every case. 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11. Then the next number will be 14, and then 14 plus 3 will be 17. Now how do we make the nth term of this kind of sequence? You may use the formula given, a plus d bracket n minus 1. A is the first term. So what is the first term in this question? It's 2. So I write 2 plus d is the common difference. What's the common difference in this question? It's 3, because we're adding plus 3 to every number. So 3 times n minus 1. Now you're supposed to simplify this. This becomes 2 plus 3n minus 3, which becomes 3n minus 1. So this is the nth term for this one, 3n minus 1. You may, let me just remove the rest. 3n minus 1. Now let's check our answer. I want to find the fourth term. Write 4 instead of n. So 3 times 4 minus 1 gives us 11. So our equation is correct. Our formula is correct. Okay. Next we have to find the 21st term. So 3 times 21 minus 1 gives us 62. Alright, this is an easy way to make the formula as well if you don't want to use the formula, and it's actually a very handy method, and we'll be using that method often in the next sequence. So learn this method as well. Instead of making this formula from the general formula given here, what we can do is, we know that in this sequence, this was 32. Alright, 3 is being added to the previous number. So you write 3n directly. Now we know our first term needs to be 2. So when I write 3 times 1, my first term is 3 at the moment, but it should be 2. So I may just subtract 1 from it to get 2. So I directly got the formula, the nth term, without using the general formula. Let me repeat what I did. I know that the common difference is 3, so I'll just write 3n. My first term is 3 right now, because 3 times 1 is 1, but the original first term needs to be 2, so I subtract 1 from it to get the nth term formula. Okay, now we'll do the rest with this new method, and I won't use the original formula. Okay, so part 4, what is happening? How is 1 changing into 5 by adding 4? How is 5 changing into 9 by adding 4, and so on. So after 17 I'll have 17 plus 4, 21, and after 21 I'll have 21 plus 4, 25. Now the nth term will be, the common difference is 4, so I directly write 4n. My first term right now is 4, but because 4 times 1 is 4, but the original nth term is 1, so I subtract 3 from it to get the nth term. So the nth term is 4n minus 3. Now the 31st term will be 4 times 31 minus 3, which is 121. Okay. Then 17, 12, 7, 2. What is happening here? We are subtracting 5 in each case, right? So 17 minus 5, 12, 12 minus 5, 7, 7 minus 5, 2. So 2 minus 5 is minus 3, and minus 3 minus 5 is minus 8. Now how do I make the nth term of this particular series? I'll use both the methods. Let's first use the formula. The formula says write the first term, which is 17, plus write the common difference, which is minus 5 times n minus 1. Open the brackets, rearrange, you get minus 5n plus 22. The second method was the direct method. Since the common difference is minus 5, I directly write minus 5n. Now my first term is minus 5, but the original first term is 17. I need to add a big number to minus 5 to get 17. So what is that number? That number is 22. So the nth term will be minus 5n plus 22. So we write that here. Minus 5n plus 22. Now to get the 31st term, you will enter in your calculators minus 5 times 31 plus 22, which gives us minus 133. Part 6, just a second. Part 6 is 18, then 15.5, then 13, then 10.5. We're subtracting 2.5 from every number. So after 10.5, subtract 2.5, we get 8. Subtract another 2.5, we get 5.5. So the nth term directly will be minus 2.5 n. My first term right now is minus 2.5, because when I substitute n is equals to 1, I get minus 2.5. But I should get 18 instead. So what do I add to minus 2.5 to get 18? That is 20.5. So plus 20.5. Or you may just use the formula, which was a plus dn minus 1. So 18 plus d was minus 2.5. So I'll write minus 2.5 bracket n minus 1. When you'll open and simplify, you'll still get this. So the nth term is minus 2.5 n plus 20.5. And the 11th term will be, instead of n, substitute 11, we will get minus 7. Part 7. The nth term, the common difference is minus 3. So after 11, I'll get 8. After 8, I'll get 5. The nth term will be minus 3n. And at the moment, my first term is minus 3, where it should be 20 instead. What do I add to minus 3? To get 20, I have to add 23. So the nth term is minus 2n plus 23. This goes here. And the 12th term will be minus 3 times 12 plus 23, which gives us minus 13. Alright, I'm discussing the sequence 6 first, because that's easier to understand and teach. So we'll do 6, 7 first, and then we'll go back to 5. Alright, so geometric sequence or exponential sequence. So part 1, 2 is changing into 4, 4 is changing into 8, 8 is changing into 16, 16 is changing into 32. What is happening? We're multiplying 2 with every number. So 32, after 32, the next number will be 32 times 2, 64. After that, the next number will be 128. So this type of sequence is called a geometric sequence, or sometimes an exponential sequence. You don't need to know what is the name of this kind of sequence. You just need to know how to find the next number and how to make the nth term. So for such sequence, to make the nth term, what do? You write the first number first, which is 2 in this case, multiply by the common ratio, which is the number you're multiplying, that's 2, and then power n minus 1. This is simply the nth term for a geometric sequence or an exponential sequence. What is happening in part 2? Again, to get the next number, we're multiplying the previous number with 2. Okay, 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Then we'll get 32 and 64. So to make the formula, we write the first term first, 1 times the common ratio, which is this number over here, 2 times n minus 1, which is the formula. You may always check if you've made the right formula or not. For the first one, 1 2 3 4 5, when you put n is equals to 5, you should get 32. You should get the value of the fifth term. Okay, part 3, what is happening here? Every number is being multiplied with 3 to get this next number. So 27 times 3 is 81, 81 times 3 is 243. The nth term is write the first number times the common ratio, which is this 3 power n minus 1. Part 4, every number is being multiplied by 2. So 24 times 2 is 48, and then 96. Nth term is write the first number times the common ratio power n minus 1. Part 5, what is happening now? Which number is being multiplied with 256 to get 64? It is times 1 over 4. Simply 64 times 1 over 4 is 16, 16 times 1 over 4 is 4, 4 times 1 over 4 is 1, and then 1 times 1 over 4 is 1 by 4. The nth term is the first term, which is 256, times the common ratio, which is 1 by 4 power n minus 1. Okay. Part 6, every number is being multiplied with minus 2. So 1 times minus 2 is minus 2, then minus 2 into minus 2 is 4, 4 into minus 2 is minus 8, minus 8 into minus 2 is 16, 16 into minus 2 is minus 32, and minus 32 into minus 32 is 64. So the nth term is first number times the common difference minus 2 power n minus whole power n minus 1. Please make a correction over here. There should be brackets around minus 2. Otherwise, you won't get the right sequence, the right nth term. Part 7, what is happening over here? How is 3 changing into 3 into under root 3? How is 3 under root 3 changing into 9? You're actually simply multiplying under root 3 with every number. So that is your common ratio. So 27 times under root 3 will be 27 under root 3. Your calculator will tell you that, even if you don't know the science behind it. And then 27 under root 3 times another under root 3 will be 81. Okay, so the nth term will be first term times, first term is 3 times under root 3, which is the common ratio, power n minus 1. Okay. And then series number 7 is simply the Fibonacci sequence. Again, you don't need to memorize the name of the sequence or any sequence. 1 1 2 3 5 8 13. Now notice what's happening. To get to 2, you're adding the previous two numbers. Then to get to 3, you're adding the previous two numbers. To get to 5, you're adding the previous two numbers. So to get to this term, you're adding these two, which give us 21, and to get the next term, you have to add 21 and 13, which is 34. We aren't supposed to know the formula for the nth term of this sequence. It's not in the syllabus. You just need to know that to find the next term, you have to add the previous two terms. The quadratic sequence, we're going to do part 3 first. So the sequence is 3, 5, 11, 21, 35. We have to add plus 2 here, we have to add plus 6 here, then 10, and then 14. What will we add next? 18. 35 plus 18 will give us 53. So we write 53 over here, 53, and then what do we add next? 22, and we get 75. So we write 75 over here. Now Notice that we're adding 2, then 6, then 10, then 14, then 18, then 22. What is the relationship between these numbers? We're adding 4 every time. So that is why this kind of sequence is called the second level common difference. It is also called a quadratic sequence because its nth term is a quadratic expression of this nature, an square plus bn plus c. Now we need to find the values of a, b, c, and then we'll have its nth term. A is always this number divided by 2. So a in this case is simply 4 over 2, 2. Keep that in mind, we'll come back to this. So a is 2n square. Next we have to find the value of b and value of c to get the nth term of a quadratic sequence. Alright, next step, to find b and c, write the original sequence again. 3, 5, 11, 21, 35. Next we subtract minus 2n square from these numbers. So the first term of minus 2n square is minus 2, because minus 2 times 1 square. The second term will be minus 2 times 2 square, which is minus 8. The third term will be minus 2 times 3 square, which is minus 18, and so on, then minus 32, and fifth term will be minus 50. Subtract these numbers and we get 1, then minus 3, then minus 7, then minus 11, then minus 15. Now notice what kind of sequence is this. We've done this kind of sequence before. What is happening here? How do we change 1 to minus 3? By subtracting 4. How do we change 3 to 4? By minus 3 to minus 7, by subtracting 4. How do we change minus 7 to minus 11? By subtracting 4, and here as well by subtracting 4. So this is actually first level common difference. And for first level common difference, we can easily find the nth term by the direct method, minus 4n. Now my nth term is minus 4, whereas my first term here is minus 4, because minus 4 times 1 is minus 4, whereas the original nth term, the original first term was 1. So how do I change my minus 4 to 1? By adding 5 to it. So minus 4n plus 5. This is simply your bn plus c. So the nth term will be 2n square minus 4n plus 5. Rewatch this if you're a little overwhelmed by the steps, by the number of steps we've done before going to the next part. So this is the answer for nth term of part 3. Okay, next I'm going to do part 4 right here. We have 2, then 4, then 8, then 14, then 22, then 32. How is 2 changing into 4? By adding 2. How is 4 changing into 8? Plus 4, then plus 6, then plus 8, then plus 10. So for the next number we add 32 should be here. For the next number, to get the next number, we add 12. So 12 plus 32 is 44. So we write 44 here, and then to get the next number we add 14 to 44 and we get 58. Okay, so 2, then 2, then 2, then 2, then 2, and then 2. So this is the second level common difference. So it is a quadratic sequence, so its nth term is an square plus bn plus c. How do we get a? By dividing this number with 2. So 2 divided by 2 is simply 1. So this is 1n square plus bn plus c. Next we need to find b and c. So clearing the screen. So I got 1n square plus bn plus c. To get the value of b and c, I write the original sequence again: 2, 4, 8, 14, 22, 32. Like I said, you may not write all the numbers, even the first 3-4 numbers will be enough. Alright, so then I subtract minus 1n square from it. So my first term is minus 1, then my second term is minus 1 times 2 square, which is minus 4, then minus 1 times 3 square, which is minus 9, minus 16, minus 25, minus 36. When subtracted, I get 1, 0, minus 1, minus 2, minus 3, minus 4. Look at this sequence. This will give you the value of B and C. This is again first level common difference because we're subtracting minus 1 in every case. Now how do I get its nth term? By writing minus 1 n. My first term right now is minus 1, because when I substitute n is equals to 1 here, I get minus 1, whereas the original first term is 1. What do I need to add to minus 1 to get to 1? That is plus 2. So I add 2 to it, and this is giving me the value of B and C. So my quadratic equation is, my nth term is 1n square, then I write minus 1n, then I write plus 2 from here. So this is the final answer. Next we're doing part 6. Let's make that the last part for today, because the rest are the same. I would like it if you would give them a shot and message me if you're unable to do them. So part 6, 1, 4, 8, 13, 19. What is happening over here? Plus 3, then plus 4, then plus 5, then plus 6. To get the next number, we'll add 7 to it, so we get 26, then 26, we add 8 to it, 34. Now, the second level common difference is 1, 1, 1, 1. This is a quadratic equation, this is a quadratic sequence, so its nth term will be in the form an square plus bn plus c. A will be this number divided by 2, so it is half n square plus bn plus c. Okay, clearing the screen. Half n square plus bn plus c. To find the values of b and c, you rewrite the original equation first, the original sequence first, subtract minus half n square from it. So the first term is minus half, the second term will be minus half times 2 square, which is minus 2, then minus half times 3 square, which is minus 4.5, then minus half times 4 square, minus 8, and then minus 12.5. Subtract this, we get 0.5, then 2, then 3.5, then 5, then 6.5, and so on. This sequence is a first level common difference sequence because we're adding plus 1.5 plus 1.5 in each case. What will be its nth term? 1.5 n. Now my first term is 1.5, the original first term is 0.5. I need to subtract 1 from it to get to 0.5, so 1.5 and minus 1. So the final the final nth term for this quadratic sequence is half n square plus 1.5 n minus 1, which is the same as this. Instead of 1.5, they've written 3 by 2. So that's all for today, and no homework for today. So enjoy the rest of your day.